In this video, we're going to be going over investigation 5.1.5. So our focus question is, how can we write a quadratic function from a graph? So one way to test whether an equation matches a graph is by testing some x values. For example, for this parabola, you know that the x inputs of -7 and 4 should make the height of the parabola equal 0. Let's go and try the first one. Notice that if I click through the tabs, it's going to show the different equations. And so for equation A, let's try plugging in 4 into my equation. Notice that when I plug 4 into the first equation, I don't get a height of 0, which it should be, right? Because in the graph, when I plug in 4, my x-intercept is at 0. So let's go and take a look at a different graph. Let's see. Oh, here's B. So it looks like when I plug in 4, the height's 0. Let's try the other point, -7. And notice that when I try -7, the height's also going to be 0. So for my two x-intercepts, 4 and -7, the equation is going to make the height is going to make y 0. So this one's going to be B. Let's go and try the next one. I know this has intercepts at -6 and -4. So let's try -4. Let's see. No, no, no. Oh, let's see. D. When I plug in -4, the height's 0. And when I plug in -6, yeah, the height's also 0. So it looks like D is going to be this equation for this graph. Let's go and try another one. Let's see, let's plug in -3 into my equation. All right, looks like it works for this one. Let's check the other ones. No, it looks like -3 is going to work for equation A. Let's see, this has answers at 0 and 4. So let's try plugging in 0. Let's see. Close. No, and all right. So it looks like equation E. When I plug in 0, the height's going to be 0. The x-intercept's at 0. And when I plug in 4, let's see, plug in 4, cancel out, height equals 4. So it looks like for my two answers, 0 and 4, the equation y equals 0. All right, we have two more. Let's try plugging in -2 into our equation. Let's see which one answers. Oh, here's C. If I plug in -2, the height's 0. The y-intercept's at 0. And when I plug in 2, the x-intercept's at 0, y equals 0. So it works for both of my points. So the equation for A5 is going to be equation C. And for this last one, let's go ahead and see. If I plug in -1/2 into my equation, right? Let's see, when does the height become 0? All right, so for equation F, when I plug in 1/2, so notice that when I plug in -1/2 and I solve, the height's going to be 0. And when I plug in 3/2 or 1.5, if I solve, the height's going to be 0. So I know that this graph has to match this equation. So here, this is explaining the situation. If we got a job at a function factory and we need to read customers' complaints in order to give them a proper parabola. So we're going to read these following customers' complaint and give them an equation that matches their situation. So let's go and see. We want a graph that has a parabola between 1, 0 and -6, 0. So we're going to write an equation where the answer is going to be -6. And that equation is going to look like x plus 6. So the reason why this is going to be part of our equation is if I plug -6 inside here, notice that -6 and 6 are going to cancel out, and then my height's going to be at 0. So the -6 is an answer to this part. The other half of the equation I can write is going to be x minus 1. So notice that if I plug 1 into this part, 1 minus 1 cancels out, and then the height's going to be at 0. So the reason why this is the equation is if I plug -6 in, the height's going to be 0. It's going to turn this part to 0. And if I plug 1 inside the equation, this part's going to turn to 0. So when I plug in both of these answers, it's either going to turn the left part to 0 or the right part to 0. And we'll see a few more examples. So here we want an equation where the only answer is going to be at 5, 0. So again, to make something equal to 5, 0, I can do x minus 5, because when I plug in 5, notice that 5 minus 5 is going to cancel out. So it's going to be 0. And if this is going to be my only answer, I can just duplicate this. And notice that I made a parabola where the only answer that would work is if I plugged in 5. So I plugged in 5, the left part would turn to 0, and the right part would turn to 0. All right, B3. Here I want my two answers to be at -3 and 2. So here I can write an equation of x plus 3. Because notice that when I plug in 3, it's going to turn to 0. And the other half is going to be x minus 2. Because when I plug in 2, it's going to turn the right part to 0. We're not quite done yet because right now our parabola is facing upward and we want it to be facing downward so that it crosses this point here. So I know that if I have a negative in front, it's going to flip it over. And there we go. Here we have a graph that matches these criteria. All right. Here, we're calling back to the water balloon contest problem we did in the previous investigation. So let's go and write an investigation for this balloon toss. So we notice that we have one intercept at 0, 0, and we have another intercept at 8, 0. So again, the equation x crosses at 0, because when I plug in 0, x turns to 0. And the other half of the equation, I want it to be at 8, so my equation is going to be x minus 8. Notice that when I plug in 8 into the equation, 8 minus 8 turns to 0, so it will make my height of the graph at 0. It will make the x-intercept appear here. This graph is also upside down, so let's go ahead and flip it over. And it doesn't seem quite tall enough yet. Let's go and see if we can double the height. And if we double the height, notice that it does match. So this is the equation for Jen's water balloon toss. Let's go and try the next one. Here we want these falling points. So the ball has an x-intercept at 16. Then it lands at, x-intercept at 10. Then it lands at 16. And has a maximum height of 27. So let's see, to get x equals 10, I want x minus 10. Because again, when I plug in 10, it's going to cancel out. I want another point at 16, so it will be x minus 16. So notice that when I plug in 16 into my answer, it's going to cancel out. And then finally, again, this parabola should be facing down so that the vertex is somewhere up here. So let's flip it over. And as it doesn't seem quite tall enough, let's go ahead and double the height. Not quite there yet. Let's go and try tripling the height. And there we go. So we have a parabola that follows this arc and hits the 3 points. All right. Here, what do we notice when we plug in different parts of the equation? So notice that all of our equations so far had this kind of format, x minus something and x minus something. So again, D and F are going to be our x-intercepts. So if I want an answer at, I don't know, 1 and 6, I can plug 1 and 6. And notice that at x minus 1, the answer is over here. And at x minus 6, the answer is going to be at 6. So whatever I subtract, that's where it's going to cross the x-axis. Right? If I want to change the sign, I can change the a part. I can make it negative. I can make it taller. I can make it shorter. So a kind of stretches the graph. So D and F are the x-intercepts. A is going to determine where the parabola faces and how much it stretches. Okay, moving on to the next part. So here, let's go ahead and write an equation. So we have a customer named Vera Vertex, and she really liked it when the graph only had one x-intercept. So let's go ahead and compare this to problem B2. So notice that for B2, here we only have one x-intercept, and this only worked when we had the same number as our answer. So the left and right part, when I multiply, only 5 turns both of these parts to 0. So again, for here, this is the same example. We have x minus 5 and x minus 5. And notice that, again, if I plug in 5 into my answer, 5 minus 5 turns this part to 0, and then 5 minus 5 turns this part to 0. So what's special about the previous parabolas? They only have one x-intercept. Another thing neat about this, notice that we're multiplying the same thing with itself. So technically, we could write this as x minus 5 squared. Right? We're multiplying with itself, where the only answer that would work would be 5. Right? Because only when I plug in 5 would it solve the parabola. So how can you use what you learned to write previous problems? We can write the same answer, multiply with itself. Or we can use an exponent. So here, let's take a look at this example. If I plug in x minus 4 squared, let's go and plug this into the graph and see what it looks like. And notice here, the x-intercept's at 4, because 4 is the only answer that would solve this. If I plug in 4, this whole thing, the whole height would turn to 0. So notice that the x-intercept is at 4, 0. And this also happens to be where the vertex is at. So the only way for a graph to cross at one point is that the x-intercept and the vertex are the same. They're both 4, 0. All right, so how can we write a quadratic function from a graph? We can use the x-intercepts and write two equations where those are the answers. Right? And basically that's kind of the gist of how we write an equation. So again, depending on where two x-intercepts are, again, we can subtract those two answers to create a parabola. All right, here we have a third example. Here we're going to make some graphs with the following conditions. So let's go and take a look at these. Again, I want to answer at -4, so x plus 4. Notice that when I plug in 4, it's going to solve the equation. Or, sorry, if I plug in -4, it's going to solve the equation. And if I plug in 2 here, if I plug in 2, notice that 2 is going to cancel out the right part, and then the height's going to be 0. So notice that we have an answer at -4 and an answer at 2. Okay? Our equations kind of look backwards to what's happening, or what our x-intercepts are. Let's go in here. We want a equation that kind of bounces off the x-intercept. So we want the answer to be at x minus 3, because when I plug in 3, it's going to be solve it. And we want this twice, right? So notice that the only answer that can solve this is going to be x equals 3. If I plug it into the left or right part, the height's going to turn to 0. Or we can write this as x minus 3 squared. All right, here we want these two answers. Again, the equation x, if I plug in 0, will be 0. If I use the equation x minus 7, if I plug in 7, this part's going to turn to 0. So this is the equation where if I plug in 0 or 7, it's going to turn either the left or right part to 0. All right, we got two more. Let's see. I want one answer to be -5, so the opposite is x plus 5. Because again, when I plug in -5, it's going to turn to 0. And the other part is going to be x minus 1. So that when I plug in 1, this part's going to turn to 0. One thing we need to note, this parabola is upside down. So let's change our a value in front. Let's switch this to negative. And now it's going to be facing the same way. All right, that's it. And so if you still have questions, please let me know. And I hope you found this video helpful.